Our lesson for today is based on Chemistry 1501, that is General Chemistry. We are going to look at Oxyanions, Lesson 102. Let us start. In Lesson 101 of Oxyanions, we looked at different types of Oxoanions or Oxyanions. Now today we'll be looking at how do other elements bond with Oxyanions to form a compound. Now, before we can actually go through the examples of the formation of elements and oxyanions, let us look at how compounds are actually formed. Now, what you need to know is that, let's say for example, we have H2O. This is the molecular formula of water. We can see that it has 2 atoms of hydrogen and 1 atom of oxygen. Now, how do we actually go about finding this subscript? There are 2 ways to actually explain this. The first method, we can say it's a crossover or cross method. The second way, it's when we actually talk about oxidation numbers. We use a more mathematical approach. So let us start with the crossover. Now, before we actually look at the crossover, let us look at the basics of the periodic table. We know that we have groups. We call this groups. It's group number 1, 2. If you consider this as 3, this will be 13, 14, 15, 16, 17, 18. But if you say it's 1, 2, this will be group number 3, 4, 5, 6, 7, and then we have 8. And then we know that our rows, we call them periods. Now for today's lesson, let us focus mainly on groups. Now what you need to know, which are the basics of the periodic table. You must know that all the elements in group number 1, their standard oxidation number is 1+. So it means when you look at the ions of these elements, all of them will contain a 1+ in group number 1. And then in group number 2, since they're in group number 2, they will have 2+. Now other groups, they don't normally behave like group number 1 and number 2. Well, some of the elements in group number 3, they have 3+, but not all of them. But you should know that this group, most of the elements, they have 3+ as their oxidation number or their standard oxidation number. In group number 4, it's a mixed, so we don't have a standard oxidation number. In group number 5, it's 3-. Then in group number 6, it's 2-. In group number 7, it's 1-. And then in group number 8, it's actually 0. We consider these elements as inert gases or noble gases. Now simply find or have your own periodic table and then simply write these charges. They will actually assist us when coming to the formation of compounds. Now let us go back to our example. Now if you can check, hydrogen is from group number 1, so it has 1+. And then hydrogen, actually oxygen, is in group number 6, it has 2-. Now using the method of crossover, let us actually rewrite this without writing the charges. Now what will happen is that this oxidation number will come here, then this one will actually come here. Let me actually rewrite this in a proper way. This will come here, then this will come here. That is why we say it's a crossover method. So we have H2O. Looking at another example, zinc chloride. Looking at this, zinc, it has 2 plus, and then chlorine has 1 minus. And then using the crossover method, you're going to have zinc 2 Cl1. Then crossing over the 2, we are going to have zinc chloride. This is one of the ways to actually explain this. Now let us look at the other way of using mathematical approach. Now we said hydrogen has 1 plus, and then we are actually reacting it with oxygen with 2 minus. Now we need to look at these oxidation numbers and the overall oxidation number of this molecule. As you can see, this molecule doesn't have any charge, it doesn't have a positive or negative, meaning that we have 0 here. So we are just going to take the sum of the two. Actually, let me say the sum of the two must result into 0. Now we have 1, which is positive 1, plus negative 2. The answer should be 0. Now in this case, we can see that 1 minus 2, when you actually distribute here, 1 minus 2 will give us negative 1, which is not equals to 0. So what can we do on the left hand side to actually obtain this 0? What we can do, we can add another hydrogen atom, meaning that we are going to have 2 1 plus. In this case, we have 2. This multiplied by this negative, we're going to have. Now you can see that indeed this side is equal to 0. So in order for us to actually form H2O, we need 2 hydrogen atoms and 1 oxygen atom. Then since we have 2 hydrogen atoms, we are going to write H2, meaning that we have 2 atoms and 1 oxygen. Now we can see mathematically the oxidation number, it adds up to 0. Looking at our second example, which is zinc. Zinc has 2 plus, and then chlorine has 1 minus. We know that the molecular formula of zinc chloride, the overall oxidation number is 0. So we need to work out our mathematical operation. Now if we can try to write this, we are going to have zinc Cl. It means we have 1 atom of zinc, 1 atom of chlorine, but this is not valid. We don't have a molecular formula like this unless we are going to put a plus charge here, because you can see that 2 minus 1, the answer will be positive 1. So this will be the answer. But if we are looking for this molecular formula, we are going to write it. Actually, let us work it out mathematically. Negative 1, it must be equals to 0. So in this case, we can see that we have 2 multiplied by, actually 2 plus negative 1, it will give us positive 1. So we need an extra chlorine atom. Then we're going to have 2 plus 1, 1, which is equals to 0. 2 plus negative 2 is equals to 0. And then 2 minus 2 is equals to 0. So you can see that this is actually correct. Now we can write it like this. This is actually the formation of compounds. Now that you understand the basics of the formation of compounds, let us look at elements bonding with the oxoanions. before we can actually look at the first example, let us review one of the oxoanions we actually discussed, which is chlorate. Now, as you can see, chlorate has 1 minus, so it means for it to actually be neutral, it needs an element that has a 1 plus. So let's say we are bonding it with one of the elements from group number 1. Let's say, for example, sodium. It has 1 plus. It's in group number 1. So bonding the two, we are going to have we call it sodium chlorate. Since we all know that this is chlorate, this is sodium, this will be sodium chlorate. Now, looking at the mathematical procedure or method, we have 0 here, so it means -1 plus 1, it will give us this, which is actually 0. Now let us look at an example whereby we are bonding an element which has actually more than 1 as the oxidation number. Ion 3, we are going to react it with chlorate. Now in this case, we are going to use the crossover, or we can use the mathematical approach. Now, as you can see that mathematically 3 plus -1, it will give us 2. But we are not looking for the ionic compound of the mixture of the two. So using the crossover, we are going to take this or consider this as a unit, or we can say one element. This will actually come here, then this will come here. We know that we only consider the numbers, so we have 1 here. We are going to have ion, there will be 1 from here, then we put it inside the bracket, ClO, then this 3 will come here. We call this ion 3 chlorate. Let us look at more examples. Let us look at this example, potassium and nitrate. Well, to form potassium nitrate, we are just going to cross over the two to form potassium nitrate. For practice, work out the following examples: calcium and carbonate. I'm not going to write the charges, you figure the charges out and work out the molecular formula. Hydrogen and carbonate. This will actually form calcium carbonate, this will form a carbonic acid. Now calcium is in group number 2, so it has 2 plus, and then carbonate, it has 2 minus. So in this case, when you cross over, we are going to have something like this. Now in this case, since these numbers are the same, we can actually say we are cancelling them out to have something like this. Now for this one, hydrogen has 1 plus, carbonate has 2 minus. So crossing over the 2, we are going to have H2CO3. So it's very important that you go through lesson 101 of oxoanions to know different types of these oxoanions, and then when you watch this lesson video, it will give you a clear picture on how most of the compounds are actually formed. This is Wahula SJ. Thank you very much.